Welcome you all to this session Automation and Control System Laboratory. Today we are going to discuss about sequencing of two-cylinder circuit. Myself, Dr. Oliver, I am going to discuss about the sequence valve. What do you mean sequence valve? A sequence valve is a pressure valve designed to open when its pressure is reached, providing a path of flow alternate and sequential to the primary circuit. It's a one type of pressure valve. The circuit are those that automatically program two or more cylinders on a machine to cause them to extend and retract in a predetermined sequential order on every cycle. Okay. So it may be extend or retract in an order we are having this valve to proceed. What is our task? So we have to design a circuit to obtain a sequential action, maybe extension or retraction. It should be in a sequence. So one or two cylinders will be there. So it has to be in sequence. So like earlier we discussed about continuous actuating cylinder. Here also we need some of the hardware elements, especially a supply unit, control units, then actuating system and connectors. So a FRL unit, 5x2 direction control valve, 3x2 roller operator limit valves, double acting cylinders and connectors and hose. So here also we use to simulate this drawn circuit in first of fluids software version 6. So sequence circuits operate actuators in a specific order. So now in what sequence it is working? How you can see there is a two cylinder, one object is moving, the object is coming. What will happen? Immediately the object is moved up and next cylinder in that sequence it has to move to the air level. Understood? This operations we call as a sequence of actions. So first we have to move the first cylinder extended, then second cylinder extended. So you can see here now first cylinder is extending, then second cylinder is extending. After that, first cylinder is moving down and second cylinder is retract. Understood? This is called sequential action. So now we can see already we have discussed so many things about the actuating devices. For example, we have so many examples we have seen for double acting cylinder, single acting cylinder with speed control, everything. So today you can see this how the action will be there. We have a compressor, we have a FRL unit, we have a push button switch, then we have two DCB for cylinder 1 and cylinder 2, and each cylinder have two limit switches. Okay, if here one limit switch we act as a push button switch. Okay, so you can see when you push immediately the system is moving. Now extension occurs for cylinder 1. From that signal, after completing the action in first cylinder, then now it is moving to the second cylinder. So second cylinder is moving. After completing this, one by one you have to retract. So this signal we are sending to the next retraction action of cylinder A. So we can see the retraction. Now we can see the retraction of cylinder B. Okay, this one we are going to simulate in fluid sim software. So now I think you understand the action of cylinder 1 and 2 or cylinder A and B. How the sensors work. Sensors means here we are using limit switches, how it is moving, you understand. So if you're not using this kind of limit switches, then also we can do with this is these are all hydraulic system. So it is moving. You can see when you have press it, immediately it is opening. It extends the cylinder. Now it is pressing. Because of that, the cylinder extends. So vertically movement, then horizontally movement. Then retraction also. You can see when you push it, immediately retraction occurs. If retraction occurs means opposite action. It has to move down. Okay. So thus we are going to connect two double acting cylinder, and now we are going to verify with using fluid sim simulation software. So now you can see here the fluid sim software. We open the fluid sim pneumatic software version 6. Go to file and take a new. So now already we know we have done continuous reciprocation. So here there we are having only one cylinder. Here we are having two cylinders. So two cylinders we need double acting cylinder. You can pick one and double click to change the name DCV double acting cylinder 1 or A 1 you can put 1. Then any other values you want to change, you can change. Configure the cylinder, whether you need cushioning or not, that you can keep. Then actuating level, you can go for A minus. Starting point is 0, 0, and the length of the stroke is 100. So 100, 100. So anything external loading conditions you want to change, you can change. Force profile you want to create, you can create. Then you can do. Okay. So now we are getting. So now you can copy this and have another one. Paste. Okay. So it is basic to do. So but the name you have to change it to B. So go to actuating level, you have to change it into B. B. Okay. So everything is. So what else we need? If there are two cylinder means we need two limit switches and two for each cylinder and one direction control valve for each cylinder. So direction control valves you have to go. One direction control valves you have to choose. What type of valve? 5/2 valves you have to choose. So you can choose 5/2 valve. You can choose 5/2 valve. So you can change everything. Okay. Then another one 3/2 valve also you have to choose. So you can have a 3/2 valve. So you have to go for rotate 180 degree you can rotate. Okay. Okay. So to change we need roller switch. So limit switch 1 and configure the value. These are all okay. Now we can spring return. Here it is mechanical action roller switch, not push button. Okay. So now I got the value. Okay. Now you can copy this. I have another 3. Paste. Here also you can paste. Also you can paste. You can adjust it. Keep it. Here is LS2, LS3, LS4. Okay. I don't have enough space. Now we go to the double direction control valve, double click and change it direction control 1 DC V1 and configure this and change it. These are all I think okay. But here it is, you have to change into pneumatically operated. No spring return, pneumatically operated. Both sides pneumatically operated. I think now it is correct. So once again I copy it and paste it here. Okay. So first part, always you have to design, you have to start from the external unit. External, that means loading condition. So from actuating element, wall, so one by one, just like that, you have to finish it. Okay, now you can connect this. You can connect this. What else we need? We are going for sequencing. What sequence? A plus, B plus, A minus, B minus. So you want to write that one means you can write A plus, A minus. Okay. Now we need a supply element. Supply element we need. So we need a is that a for unit. Then we are having a compressor unit. Okay. So like this. Like this. Okay. So all units you have to connect. Yeah. So you connect. Also you have to connect. Okay. So now we missed one thing. We have to configure this A minus. Here also A plus. To configure this. Okay. Press it in the roller. Double click in roller. Okay. A small letter B minus B plus. Okay. So I think all are configured. So now basic connections are over. Now what is the sequence? A plus, B plus, A minus, B minus. So first you have to start from the last B minus. So B minus, from here you have to go for the next action. You have to go for B minus, then you have to go for A plus. Okay. So you can go like this. Okay. So it is a pilot operation. So you can have a drawing properties. You go there and keep it in a red color or any other color. So then you can go for dotted line, go for the thick line. Okay. So you can easily identify the moments. Okay. Now V minus, then A plus. So immediately it moves. So we are getting A plus. So from here A plus to B plus, A plus B plus. Okay. So this line also you have to keep it as a drawing line with the color. the dotted line with a thickness of 3.3. Okay, now easily identified main line and the pilot lines. Then A plus, then immediately B plus, afterwards A minus. So from here, we have to go for A minus. Now it reaches this area, we have to go for A minus. So this line also you click it, go and change the properties into different color. You want to have different color also you can do. So you can have this dotted line. So dotted line means sending the signal. So now after this A minus, then you have to go for B minus. So this you have to from A minus to B minus. Understood? So here also you double click, change the drawing properties into color change, then you go for line style, then you go for the thickness. Okay. So now all the connections are over. If the exhaust lines are not closed means you have to double click and close it. All other connections are over. Okay. So understand? Once again I'm telling you we are having two cylinders, cylinder A, cylinder B. Each cylinder have two limit switches LS1 and LS2, similarly LS3 and LS4, and two 5x2 pilot operated valves we are having as a direction control valve for each cylinder. Now we need to design a sequence of, or we have to build a sequence of A plus, B plus, A minus, B minus. So always you start from the last action is B minus. From B minus you have to go for the next action. So you have to go for B minus from next action. So you can have B minus to A plus. So we are sending the signal to left side of the DCV1. Then immediately cylinder extend. We reach A plus. Then A plus to DCV2. So we are getting B plus. After B plus, you have to go for A minus. So that signal we sent to the right side of the DCV1. After completing A plus, B plus, and A minus, you have to go for B minus. So it's sending the signal to that. I think you understand how to draw the circuit for a sequence of A plus, B plus, A minus, B minus. Now we go for the execution. We go to home. We go for the execute. Start. Very easily. But we are enjoying this video. Questions?